All right, good morning, everyone. Looks like most folks have jumped on, so would like to welcome you to Finding SRF Funding with New Incentives, Cyber-Formed Engineering. For those of you that don't know me, my name is Nicolas Hiebert. I'm a water quality engineer with DEQ. Also joined by my colleague, Rosemary Regner, also an engineer with DEQ. And we're excited for today's presentation. We're hopeful. Our goal for this presentation is that you'll come away with some new tools, some new information. Hopefully, if you're like me, to come away maybe a little bit less intimidated about the concept of cybersecurity, and maybe even intrigued by the concept of cyber-informed engineering. So, with that, next slide, Jade. Okay, before we get going though, we do need to get a few housekeeping items under our belt. This presentation is being recorded, so if you need to step away from your desk, or if you need to come back and watch this or share it with folks, we will provide a link to that transcription on our YouTube page to those who are signed up for this webinar. You will be muted. Attendees will be muted during the presentation. At the end, you will have the ability to raise your hand and come off mute to ask questions. You're also free to put those questions in the chat during the presentation, and we can come back to those at the end and answer, or at least attempt to answer all your questions at the end. All right, so let's dive in a little bit into the details here with the presentation. We'll get going with next slide. Talk about the agenda. No presentation would be complete without an agenda. So here's where we're headed. I'm going to talk a little bit about the backstory of cyber-informed engineering, how we got here. Rosemary is going to dive into the details of cyber-informed engineering, what it looks like, how it works, and then we'll finish it off with how it is incorporated into the SRF funding and what the implementation and next steps will look like for that. All right, so why cybersecurity? How did we get here? So there's a few things that have been happening over the last, we'll say, last decade or so. Cybersecurity is becoming increasingly more of an issue in the water sector. We're seeing, over the last decade, we're seeing more and more of our critical infrastructure being accessible on the web. What operator doesn't want to be able to pull up his smartphone and operate his water treatment plant or wastewater treatment plant from the convenience of his home? And there's a lot of benefits, a lot of efficiencies that have come from that, but it's really put a lot of our critical water assets at risk. And it's something that has been a known issue for a while now, and it's just continuing to compound. So it is an issue, right? And it's an issue throughout the different industries, but it's really come into focus in the water sector in the last decade or so. And so we've seen a lot of different movement happening, a lot of different kind of that storm cloud, that black storm cloud out on the horizon that we're anticipating. There's been a few things in the last couple of years that have really kind of ramped that up. Specifically in the last year, the White House sent a letter directly to Governor Little's office and directing them, I would say, with a strongly worded request to develop a water sector cybersecurity plan. And so Governor Little then in turn is looking at DEQ, and DEQ, we partnered with Idaho Office of Emergency Management, and we developed that cybersecurity plan. We checked the box, essentially. It's a reactive, it was a reactive response to a known issue. And in the same way, EPA, has been trying to find a way to enforce cybersecurity requirements in the water sector. We saw that with a couple of years ago with trying to incorporate cybersecurity into our annual sanitary surveys of drinking water systems. We're now seeing that with an emphasis in trying to incorporate cybersecurity into emergency response plans as for drinking water systems. And so there's again a real emphasis in how are we addressing cybersecurity in the water sector. And what we've observed at DEQ over the years is when something comes into the target, um, and folks are trying to find a way to enforce it, it's kind of the stick or the carrot approach. And typically what happens is then if we can't enforce it with a stick, we then incentivize it with a carrot. And so that's kind of what we're anticipating with the SRF program. The SRF program obviously is a way to incentivize things. And so we're anticipating that the SRF program, DEQ, is going to see requirements set on our SRF funding that's then going to have to be passed along to our recipients. And so really what we're looking at is how can we proactively find a common sense approach to addressing cybersecurity. It's something that we've been looking at, something that we've been talking about for several years now. We really would rather not just have another checkbox in the SRF program. We really want to look at this holistically because it is an issue that we want to be able to help systems address through SRF funding. And so how can we find a proactive, common sense approach that actually makes a difference and isn't just a paperwork exercise? That's really what we've been looking for. And so a few years ago, around 2020, this idea of cyber-informed engineering came across our desks, and it was intriguing, to be quite honestly. Very intriguing, very exciting, because it's a completely, I'll say, different mindset to what I think of when I think of cybersecurity. And it really starts with the premises that the best cybersecurity solutions, the best software, security software, the best firewalls, they really act like basically like a speed bump for the bad actors. It slows them down, but it's not going to keep them out. And so all of this emphasis, all of this kind of reactive back end emphasis of we build the system, we design the system, we build the system, and then after it's all constructed and it's in operation, then we try to figure out how to make it secure. That whole process, that whole model, it kind of flips it, so to speak, on its head and says, okay, we're gonna rewind this all the way back to the planning phase, and we're gonna assume that these bad actors are going to get into our system that we're designing. We're going to assume that they're going to get in. So what are we going to do about it now? What are we going to do about it in the design process? How can we design this system so that when they get in, they can't do anything, right? Or when they get in, the impacts of that malicious effort, we can live with it. It's mitigated. How do we find that balance between providing those dynamic remote solutions for operators, but at the same time building into the system, building into the designs of the system, security measures, mechanical, physical security measures that will limit or completely thwart any malicious activity when we get hacked. And so that's cyber-informed engineering in a nutshell, in the most simplistic form. And it's really exciting to me too, because this concept is really it's really something that it's not new. It's close to 10 years old, I think. But it's something that was born in Idaho. It was Idaho National Laboratory folks came up with this concept, started pioneering this concept in the energy field, in the nuclear field. And it has, to me, it makes so much sense that it has now infiltrated its way into the different industries, and the water sector being one of those industries. It seems to me like it's just a fantastic fit. As soon as we heard about this, it seems like, man, the glove just fits. That now we can approach cybersecurity in a way that makes common sense. It's proactive. We're not being reactive towards these bad actors. We're actually designing into our system mechanical, physical controls that's gonna limit the damage when these hacks occur, not if, but when. And so to me, a common sense approach, it's exciting. So we're excited to introduce this topic. Some of you are probably already aware of it. And we're excited to see, we're learning together in this process. And so we're excited to see where it goes in the years to come. So part of the landscape of Idaho, why we feel like this makes so much sense is just we have a lot of really small rural water and wastewater systems. So you can see the numbers there. A lot of these water and wastewater systems that we serve are very small. For example, drinking water systems, 99% of our drinking water systems are less than 10,000 in population, and 97% are less than 3,300 in population. So we're talking about systems that, quite frankly, might have a city clerk and a couple of operational staff. And so we're not looking at large systems. We're looking at systems that don't really have the capacity or the resources or the time to reactively focus on IT issues. And so designing systems up front to help these smaller systems, I think, is a great fit even for the landscape of small and rural communities, which, quite frankly, a lot of our SRF funding, goes to these smaller systems to help with. And so a lot of the cybersecurity efforts that are going on right now are focusing on the big systems. And we feel like in a lot of ways that's really leaving out these smaller systems, and many times are just as vulnerable to cyber attacks as the large systems. And so this is one way that cyber-informed engineering can look at systems across the board and provide proactive solutions to addressing cybersecurity issues. So we think it's a great fit. We're excited to see how it works, and we're going to dive a little bit into more into the details now. So Rosemary is going to, again, like I said, dive into the details a little bit of cyber-informed engineering, how it works, what it looks like, and then we'll come back after that to the implementation side of things. So with that, take it away, Rosemary.
Okay. Okay, cybersecurity typically it has been very focused on the IT side, which is, Nicolas just kind of went over that. I call it a giant game of whack-a-mole because it just like, no matter what we do, we try to keep them out, keep the hackers out, but the hackers just get smarter and find other ways to get in. It can be expensive and complex, and as a design engineer, it's not something that I'm an expert in, but it's the reality of this is the way the focus has been for cybersecurity so far. Cyber-informed engineering is really a mindset of how you go about designing your system so that you can minimize the damage somebody can do from the outside. It's a method where you consider cybersecurity from the very beginning of the planning stages, and you carry it throughout the construction and the life cycle of the whole plant. CAE uses design decisions and engineering controls to create a safety barrier for your systems. It gives you a framework of how you engineer out the cyber risks throughout the whole life cycle of the plant. It's focused on the engineers and operators, which I think is really important because that's really your boots on the ground people that can protect your plant. And the cybersecurity actually also, looking at it from the CIE perspective, it adds additional functionality, safety, and reliability and resiliency for your plant. So you're getting a whole lot more than just the cyber aspect of it. So this slide kind of gives you a diagram, lays out the different parts of the system. You have the information technology, the IT side, then operational technology, and then the industrial control system is really what's on your plant. It's your equipment, it's your valves, it's your switches, it's everything on your plant is in the ICS side. Like we said, a lot of cybersecurity has been, I think, too focused on just the IT and OT and on the software side on trying to beef that up. And CIE wants you to look at the equipment that's on your plant. Look at the control systems and basically go back to introducing and engineering in old school ways to protect your systems and operate them. To me, as a design engineer, I get excited about this because I get this. Like somebody tells me to engineer backup controls like old school way, I get that. And to me, the first time I ever heard about this, I just got super excited because it just makes sense. And it's a different way of, one way it's different in the design aspect is that right now you design your plant, get your specs, you go for construction. Sometime during construction, the SCADA is developed, and then the IT, cybersecurity portion gets wrapped in kind of at the end. CIE wants you to start at the very, very beginning and then carry the cybersecurity aspects all the way through the entire design. So CIE has 12 principles. And this is basically just like a roadmap of how they recommend the approach of how you would do an analysis. Don't be intimidated that there's 12, because you may not need all 12 on every system that you're designing. But right now, we're just going to really focus on 2 of the principles. The first one is you need to look at your system and figure out what are the critical functions and how bad could it be if somebody messed with them or got in there and hacked my system, or, you know, it could be an internal. Some of the internal could be mad and does something to the plant. Then the next step is the engineering. How can you, what kind of engineering controls can you add to your design to help minimize or stop somebody from doing damage to your system? So the first step, identify your critical systems. You know, what systems support the critical functions at your facility? And what systems control the critical processes? What systems can never go down, that they have to be running constantly, or your systems, your public health could be at risk? And then also, there are some built-in storage on the collector systems and some of the tanks and stuff, but how long could a system be down, or your system be down, and you could still manage? I mean, these are just all things to think about as you're looking at critical systems. Also look at, can the systems be hacked? Are the critical systems connected to the internet, or are they controlled by SCADA? And it's a basic premise, come back to, they will be hacked, now what? I think in addition to this, the one thing I didn't bring up is on that previous slide. I've heard a lot of people saying how they're getting pressure to put their SCADA systems in the cloud. And one question I have is, if you do that, what happens if you lose internet? I mean, so in some respects, if you lose internet and you do choose to put your SCADA in the cloud, how are you going to be able to still operate your plant when internet goes down? And it always goes down. So that's like another layer of safety that you're being built in by following the CIE principles of design engineering on the physical aspect of it. So if you're hacked, how are you going to run your plant? I mean, one thing is, I call it old school engineering. I mean, I was around back when we had relays and hardwired everything. And, you know, if you have a level sensor that's a critical measurement on your plant, you could put in float switches to actually provide, you know, basic functionality in case you lose your level sensor. You can put in pressure switches, you know, either low pressure or high pressure, to help protect your equipment. And if you have a storage chemical tank, you could actually put in a day tank in between your chemical pump and the storage tank, so that the day tank would, like a bad actor could get access to the day tank, but then you're limiting how much damage they could do. Now, you don't want to have, so you're limiting how much they actually could introduce into your system. And you also need to look at alternate ways for controlling your system outside of SCADA. It's, you know, just kind of old school again. Can you manually operate your plant? And that's kind of a lost art, that's the way plants used to be run. And automation really made the systems more efficient. But at the same standpoint, you can't forget about how to do that. If you lose your SCADA, could you actually manually operate your plant? And this should actually be part of your emergency response plan, and it should be periodically practiced. I mean, periodically, you have a day without SCADA or an hour without SCADA, and how are you going to keep everything running and keep public health issues at bay? The other thing is, you could potentially have, if you really need a PLC to control a system, you could have it as an isolated PLC that's not connected to, it has its own internal network. and it only sends status and alarms to the SCADA. SCADA does not control it. And here are some examples. I mean, this is a question you have to ask yourself, is CIE says, assume you're going to be breached as you look at your designs. And so, one example, how do you protect a main overpressure? Well, you can put in pressure switches at each pump. And the key to this is that that pressure switch needs to be wired directly into the motor controller, not through the PLC, because that kind of takes away the whole purpose of doing this. But just having that pressure switch in there wired directly to the controller means that pump, that pressure switch will operate that pump or keep it from going into an overpressure in case that you don't have a PLC or a SCADA system. A chemical pump, how would you protect chemical pumps? Well, the day tank we talked about, you could just put a day tank in to limit how much chemical somebody could have access to at a given time. If you don't have, you could have isolated PLC control if you don't have SCADA. You could put in timers to limit the operation. Nicolas had one more. Nicolas, what was that other point?
Yeah, so again, brainstorming here, another idea was, if you have a chemical feed pump, look at the range of operation of that chemical feed pump. Maybe by narrowing the range of that chemical feed pump, if a bad actor were to hack it, they couldn't ramp it all the way up or ramp it all the way down, because the actual physical elements of that chemical feed pump, would limit the damage that could be done.
So that's just a very brief introduction to what CIE is about. And I hope we get other people as excited about it as we are, because I just think it's really awesome. Now we're turned back to Nicolas, and he's going to talk about the incentives.
All right, so now we're getting to the part in the presentation where we're going to kind of turn towards the SRF funding and how we kind of envision, at least initially, how this will could potentially really integrate well into the SRF process. And so, all right, so most of you are probably familiar with our letter of interest process. I'm not going to go into great detail on that, but each year we, basically we solicit interest for SRF funding through our letter of interest process, and it's a competitive ranking process in which you fill out a letter of interest, and based on the scope of your project and what you're planning on doing, you receive points that then allow you to rank on a fundable list. And the highest ranked projects are the ones that typically get funded. Moving down the list, lower ranked projects typically don't receive funding. We have a whole lot more demand than we have funding, and so it's a very, very competitive process. And quite honestly, a majority of our fundable lists do not get funding just because of how high the demand is and our limited amount of funding. So as part of our letter of interest process, we looked at that and we said, this cyber-informed engineering, A, it makes good sense, and then B, we really want to get out ahead of this. Again, the cybersecurity requirements are more than likely coming to the SRF program, so let's do something that actually makes sense, and let's get out in front of it so that we can demonstrate what this looks like and how this can be implemented in a in a really effective manner. And so we created a new incentive. Those of you that are familiar with our LOI process, there's a sustainability infrastructure efforts section. And so under that, we've created a new incentive under question 1A, and we can zoom in next. And you can see that in the planning grants. And so we have, generally speaking, we have two different kinds of LOIs. We got the planning grants LOI, so it's the planning efforts, and then we've got the construction side. And so in the planning grant efforts, we really envision that this would look like including the cyber-formed engineering analysis into the facility plan for that selective alternative. So you can see here, the question says, as part of a planning effort, cyber-informed engineering principles will be incorporated, critical systems will be identified, and plans to integrate CIE into future projects will be developed. And it's worth 20 points. So again, in this section, most questions are worth 5 points. And so we thought, we would throw a little bit more points at this question than we normally would. 20 points is enough to tip the scales. Again, in a competitive ranking scenario, it's not a lot, but it's enough that it could tip. We believe it could tip the scales of whether a project is funded or not. And so, again, this is on the planning grant side. Very similar on the construction loan side, except we've moved past the planning. It's not just a planning effort anymore. We've actually moved into we're building the project. And so the question here looks a little bit different. And so in this instance, again, it's not planning, it's actual construction. So the project design will implement cyber-informed engineering analysis and incorporate the recommended security measures into the project. It needs to be incorporated in plans and specs. It needs to be reviewed and approved by DEQ. And so at this point, what we envision is we've gone from the planning stage, and now we're actually we're going to design that chemical feed pump with the CIE lens, and it might modify the design. It might not. Again, every project is going to be really unique. Are we talking about a complicated water treatment plant, or are we talking about a single well with a tank? The CIE analysis is going to be very different for those two types of systems, and we'll talk about that a little bit more. All right, so what does it actually look like in practice? So consistent with the sustainability infrastructure efforts section of our LOIs, if you check the box for any of these items, it's going to be incorporated into your funding agreement. And if it's incorporated into your funding agreement, you and your engineer are going to need to evaluate and complete each item under the terms of that agreement. And so for the planning grants, again, we've kind of already talked about this, but we anticipate that analysis would be included in the facility plan based on the selected alternative. And that level of detail is going to really vary depending on what we're talking about. Similarly, with the construction loans, what in an ideal world, the way our system works, the planning grants a facility plan would kind of tee you up for the project. And so you would pull that CIE analysis from the facility plan into the preliminary engineering report and design. For some projects, you might not have the convenience of having that facility plan already thinking about CIE. So you might have to really ramp that up in the PER phase of the project and start from scratch and say, okay, how are we going to address this CIE lens in the preliminary engineering report, define that design criteria of what CIE would look like, and then move that incorporate it into the final design. And so again, this is kind of what we envision it looking like. Along with that, we want to come back to this idea that really the CIE is it's just really a mindset. Like we're not looking to create, a lot of extra work or a lot of extra analysis in these projects. What it's really doing is we're hoping that it's going to trigger a mindset that we should be asking these questions up front, not after we've constructed the project. And they're simple questions, they're common sense solutions oftentimes. And as an industry, I believe, as we develop this mindset, it's going to be, I think, pretty much second nature to start asking these questions. I think about it a little bit like how in years past, adding VFDs into a pumping system variable frequency drives into a pumping system was kind of a novel thought. And over the last several decades, it's pretty rare to see a major pumping system go in without a VFD. The industry has caught up. Prices have come down. It provides operational flexibility. It just makes sense. And so our hope is that as this continues to develop it through the industry, it's just going to make sense, and we're going to become routine questions that we ask in the planning and design phase. Along with that, we are hoping to develop some tools, some resources that will be housed in our customer handbook. We're not exactly sure what those will look like, checklists, list of questions, something along those lines to get that mindset, to give you tools to exercise that mindset as we move into this concept. And again, the goal is flexibility. No two systems are going to be alike. No two systems are going to have the same CIE approach. And so we really want to try to build in, flexibility to make this work and to make sense at the same time. All right, so moving forward, we do plan to evaluate this incentive annually. We want to hear back from everyone in the industry, and we want to hear back from recipients. We want this to make sense. If it doesn't make sense, we don't want to do it. We need to be able to adjust and make changes, so that this makes sense, so that it is a common sense approach. And at the end of the day, it's something that we need to address. We're not going to get around cybersecurity. It's just the world that we live in. And so I don't see that the issue going away, but I see, we hope that this will be potentially a solution that really works for everyone. And I believe that it's where the industry is kind of going. So I think we're just kind of on the leading edge of where the industry is going. AWWA is working on a CIE water sector guidance. From what we've heard, we anticipate that coming out sometime end of 2025. So we're super excited about that. And again, we're not going to try to reinvent the wheel here. I think there's a lot of resources that are going to be coming for the water, specifically for the water sector. We're anticipating a small system training or certification resources for CIE from AWWA. So I think there's going to be a lot of resources in the next year or two that come out that really help shape our approach and really help move us as an industry in the right direction. So we're definitely keeping our ears to the ground for those movements, and we're excited to see what comes from that as well. Okay, along those lines, INL, Ginger and her team have indicated that they'll be willing to provide a water sector deep dive into the CIE interworkings. And so that has been kind of tentatively penciled for end of January sometime. And so I'm looking forward to attending that, because I learn something new every time. And so stay tuned for that. We'll make sure to push that out to everyone who attended this, and it'll go up. I'm sure it'll go out with our media blasts if you're signed up for those. So keep your eye out for that. I think that's going to be super helpful. Again, we just kind of skimmed the top, and this will allow us to go a little bit deeper in next. And then also, we do have, like I mentioned, we will have this recording on our YouTube playlist channel, so you can come back to and look at it. And these resources will be on our website. They're listed on the screen, so you can have access to these slides afterwards. You can go navigate to that easily enough. So with that, we are getting close to the end here. Before we pause to take questions, it looks like we got plenty of time. I do just want to say a special thanks to Ginger and INL, her team, for all the resources, for Andrew and Wes Yost. They've provided us a lot of support, a lot of expertise through this process. And, again, we're not the cybersecurity experts, but, we're certainly thankful for the expertise that they've provided us, and that it will continue to provide for us as an industry. So yeah, with that, we'd like to open it up to any discussions or questions. If you left a question in the chat, Rosemary will grab those. And then if you'd like to, you can raise your hand, and I believe you can come off mute and ask your question. So Rosemary, do we got any questions in the chat?
Yes. Is the cyber-informed engineering workbook referenced earlier in the presentation linked on the DEQ website? No, it's linked, and we're going to send out a PDF of the slides. It's there, but we can certainly put it up there. I don't see an issue. We could probably copy and put it in here. I'll copy and put it in the chat.
Perfect. I was just going to suggest that. So those are all resources of all the resources you saw during this presentation are all publicly available. Much of them have originated with Idaho National Laboratories and are available. We have links to their website. You can go directly to that and find a wealth of information. Again, we're just kind of touching the tip of the iceberg here with the depth of information that you can look at. So to answer the question, those resources are available.
Another question. Any insights into the interaction of CIE and the energy side, not just the water side? Maybe, I know we have some INL folks on here. Maybe you could answer that question.
I'll just kind of jump in here really quick. Yeah, so as we kind of talked, and maybe I don't understand the question entirely, but as we kind of talked, the CIE concept was born out of the energy industry, so the nuclear industry, and so it fits really well with complex systems, right, where there's a lot of different critical um, infrastructure components. If you think of like a water treatment plant, there's a lot of different parts and pieces that have to work or the system fails. And so we believe that's why it's such a good fit with the water industry, but it was born in the energy industry and it fits, well with the energy industry as obviously. So I don't know if that answered the question, but yeah.
Okay, so if somebody wants to speak, they should be able to unmute themselves now.
Thank you all. This is Ginger Wright from the Idaho National Laboratory. First of all, thank you, Idaho DEQ, for bringing cyber-informed engineering to this group's attention. We are exceptionally interested in your feedback on this process. We're putting some resources in the chat, both things that apply specifically to the water sector, but also some things that apply to the energy sector which is more of our delivery focus. So we don't want to distract anybody into energy, but if you do have systems that span water and energy, maybe a water system that uses a battery energy storage system as a part of its resilience strategy, we can certainly offer resources that help you think about cybersecurity according to the engineering purpose and the critical functions of both of those systems aligned, and prioritize how you would apply cybersecurity so that you apply them to those critical functions, additionally to the hygienic things that are kind of baseline cybersecurity practices.
Awesome. Thank you. Thank you, Ginger. Any other questions in the chat?
Another
Rosemary?
question. You mentioned CIE through the SRF program as the carrot. Do you have any insights into what the stick may be?
Good question. That's a great question, and I think that's a question we've all been asking for a while now. And no, I don't have any insights, and I don't really want to have any insights into that. I think I would rather do things that make sense for systems instead of implementing things one size fits all approach that oftentimes we see when it comes to the stick. So hopefully if our thoughts are if we can be proactive, there we won't need to answer that question. But it is something that we're aware of that could be something that we have to deal with as an industry.
Somebody has their hand raised. Orlando?
Yes, I left a message in the chat, and I noticed on the news today that China was using text messaging, SMS, in order to hack the phone. And I know that some operators will link their phones to systems in order to get to SCADA or whatever other forms they need to get to. Has this been addressed yet? About phones being able to be used and processed as a hacking device into your system? Does that make sense?
Yeah, I think it's a great question. I think it further, in my mind, Orlando, it further strengthens the concept that these systems are our systems are probably going to get hacked because of all the different avenues into the water system. So I think my hope is that as we ask these questions as an industry, that we're going to help steer some of these vulnerabilities through the process. I don't know what that will look like, but I think it's a conversation that, man, if we can have it early in the design process and throughout the whole process, and especially helping communities and operators understand some of these vulnerabilities, and then even designing into these systems that when they get hacked through the cell phone, that we're really limiting the damage, because it's going to happen, and it is happening. Like you said, if you watch the news, it's a water system here gets hacked, and then the next day a wastewater system gets hacked, and unfortunately we haven't seen anything catastrophic from a public health standpoint, but it is happening. So it's a great question.
And in addition to that, so we keep emphasizing somebody hacking in, but another threat could be a disgruntled employee, or there's other ways that you can be at risk. In addition, we keep talking about just hacking, but it's a little more, there's a little more to it than just, there's more than one avenue that somebody can get in. Chelsea asks, would you consider putting together an FAQ page on our SRF page, or DEQ SRF page?
Yeah, that's a great suggestion, Chelsea. What we envision is our customer handbook would house, and we're currently looking at developing something similar to an FAQ, something that provides kind of a baseline and then points folks in the direction for additional resources and guides systems in how to approach CIE. So I think it's something that's coming. We're not quite there yet. All right. Any other questions or comments? Okay. Well, I appreciate everybody's time. Like I said, we will send out to the attendees. We'll send out the slides here and the link to this recording. Again, I appreciate everybody's time. This is exciting, and we'll keep you informed as this topic develops, and we'll see where it heads. So thank you, everyone. Have a great day.